right, lesson 2 in unit 2 is the change in linear and exponential functions. So the skills and learning objectives of this lesson are we're going to construct functions of the real numbers that are comparable to arithmetic and geometric sequences. We're going to describe similarities and differences between linear and exponential functions, and we're going to solve real-world applications using arithmetic and geometric sequences. So it says, let's look at the relationships between linear functions and arithmetic sequences. We know that a linear function of the form y equals mx plus b describes a continuous function whose domain and range is all real numbers. The y-intercept is a point 0, b, and the rate of change of the function is the value of m, which represents the slope of the line over its domain. Arithmetic sequences can be represented by linear functions. However, sequences and their corresponding functions may have different domains. So example 1 here, it says use the graph of the sequence shown at the right to, and A wants us to complete the table below. So let's do that. So we can see that when x is 1, they already told us it's -5. When x is 2, we can see it's at -3. 3 is at -1. 4 is at +1. 5 is at 3. And 6 is up at +5. And so seeing our pattern there, we know that as we go this way, we're just adding 2. So if I'm going to go the opposite direction, I would subtract 2. So at 0, it's going to be -7. So B says to find the difference, D, and write an explicit rule, A sub n. All right, so my difference is we're adding 2 each time. So it's going to be 2. Now the explicit rule, we really worked with that general rule a lot in 2.1. The explicit rule said that A sub n was equal to A sub k plus D times n minus k. So we just need to pick one of these other points. And so I'm just going to pick the first point when n is 1. And so we know then that A sub n will equal, if I'm using A sub 1, then that would be -5 plus the difference, which we said is 2, times n minus, and if I'm looking at A sub 1, the k value there is 1. And so there is an explicit rule. And there's several explicit rules, okay? We could have used the 0.65. In that case, our equation would be different, but if we work them out, even if we use the general rule, if we work them out, we're all going to get the same exact thing. And so C says to use the information from part B to write a linear function that corresponds to the nth term expression. So this is where we could work this out. So we know that it's going to be the equation, so let's do that. So A sub n is equal to -5 plus 2 times n minus 1, which is -5 plus 2n minus 2, which is going to give us 2n minus 7. And so to write the linear function, we would say f of n is equal to 2x minus 7. Now if you look at this, this fits our general rule, okay? So remember our general rule was A sub n equals dn plus the 0th term. And so we'd have A sub n equals d, which is 2n, which I should have put an n here, not an x, I apologize. If I'd have put x there, then I should have put x in f of x. So 2n, and our term at 0, if you look up there in the table, the first term would be A sub 1, that would be the -5, but the A sub 0 then is right there, it's -7. And so that's the same exact equation we just came up with for the linear one. All right, so they'll all work out to be the same no matter which one we use for the explicit. All right, example 2. Says given the arithmetic sequence where A sub 1 equals 17 and A sub 8 equals -39, state the domain and range of the sequence. All right, well, we know it's arithmetic, so we know it's going to follow like a linear pattern. So therefore, we know we're going to have a slope, which our slope is also going to be our common difference. All right, so our D is equal to the slope. And since we have 2 points here, we know that slope is just y2 minus y1 over x2 minus x1. And so we can use that here. So we have -39 minus 17 over 8 minus 1. So it's at negative 56 over 7, which is negative 8. And so we know our common difference is going to be negative 8. And so using that, we can go ahead and fill in our table. So 17 minus 8, minus 8, minus 8, minus 8, minus 8, minus 8, and then check it. Minus 8 is negative 39. All right, now we want the domain of the range, or the domain is just going to be those x values, or in this case, those n values. So 1, 2, 3, 4, 5, 6, 7, 8. And the range is just going to be those y values. So 17, 9, 1, negative 7, negative 15, negative 23, negative 31, and negative 39. Example 3 says write a linear function whose domain is all real numbers that will contain the domain of the sequence in example 2. Show your steps for writing the function. All right, so depends if you want to do the general or the explicit. First off, I'll just start with the general. So we know that our common difference is negative 8, we said. Our 0 term, well, we'd have to back it up here. So if I go back to 0, I would add 8 because I'm going to the left, so that would be what, 25? And so we know that our equation a sub n will equal d times n plus the 0 term. If you want to use the explicit form, we can just pick any of them. Let's just pick 1 and 17. So we would know that a sub n would equal 17 plus our difference, which is negative 8, times n minus k. We picked k was 1 because we picked the first term. So this is 17 minus 8n plus 8. Just gives me 25 minus 8n, the same equation. So either way we do this, so we come up with the linear function. So it's the f of n equals, and we can write it as 25 minus 8n, or negative 8n plus 25. It doesn't matter which way. All right, arithmetic sequences and function notation. The explicit rule denotes the nth term of a sequence where n tells the term's location. It defines a sequence as a formula in terms of n. It may be written in either subscript notation, a sub n, or by using function notation, f of n. So example 4 says given the sequence 32, 27, 22, 17, 12, 7, find an explicit formula in both subscript notation and function notation. So it told us that our first term was 32, our second term is 27. I'm just reading up here in that list that they gave us. Third term's 22, then it was 17, then it was 12, and it was 7, and we could keep going. So the term number is 1, its subscript is a sub 1, so the second term would be a sub 2, third term's a sub 3, fourth term's a sub 4, fifth term's a sub 5, sixth term's a sub 6, the nth term would just be a sub n. And then it wants function notation. Well, the first term is f of 1, so the second term will be f of 2, third term is f of 3, fourth term is f of 4, fifth term is f of 5, sixth term is f of 6, and the nth term would just be f of n. All right, now it wants us to write it in subscript notation. So it's up to you if you want to use the subscript notation is the a sub n one, so you can use the general form of the explicit. I'm just going to be lazy right now. I'm just going to use the explicit form because they didn't give me the 0 term, and I'm just being lazy. So I know a sub n equals my a sub 1, which is 32, plus the difference. What was our difference? We didn't actually say what it was. Our difference is we're subtracting 5. So negative 5 times n minus, and 32 is our first term, so minus 1. All right, so a sub n equals 32 minus 5 times n minus 1. And so my function notation, though, I could work this out. So this would be what, 32 minus 5n plus 5. And so I would get 37 minus 5n. So that way it's written in linear function. All right, example 5. It says given the explicit formula for the sequence f of n equals 9 minus 3 times n minus 4, write the first 10 terms of the sequence. All right, so I'm not going to write a sub 1 equals a sub 2 equals all that. I'm just going to write out the first 10. So if I plug in 1 here, 1 minus 3, from 1 minus 4 is negative 3 times negative 3 is 9 plus 9 is 18. So my first term is going to be 18. And then when I plug in a 2, 2 minus 4 is negative 2 times the negative 3 is 6 plus the 9 is 15. When I plug in 3 minus 4 is negative 1 times the negative 3 in front is 3 plus the 9 is 12. And so I can see here my difference is subtracting 3. So my next one's going to be 9. My fifth term would be 6, 3, 0. What number is that? 1, 2, 3, 4, 5, 6, 7. That's my seventh term. So my eighth term, my ninth term, and my 10th term. And so there are the first 10 terms of that sequence. Now B says to find the 200th term of the sequence and support with work. Well, that means I'm just going to have to plug in. If I'm looking for the 200th term, then n is going to be 200. So I got 9 minus 3 times 200 minus 4. So that's 9 minus 3 times 196. And so this is going to give me negative 579. So negative 579 will be my 200th term. Then we'll also write the slope-intercept form of the formula. So they gave me f of n equals 9 minus 3 times n minus 4. We just need to simplify that. So we got 9 minus 3n plus 12. So negative 3n plus 21. And so there's our slope-intercept form of that formula. All right, example 6 says Elizabeth waters her vegetable garden using water she collects in a 55-gallon rain barrel. On May the 3rd, the barrel was full of water. On May the 8th, the barrel contained 47 gallons of water. Write the first 6 terms of the sequence. Well, let's see. Our first day, so I'm going to let my a sub 0 be May the 3rd. And it had, whoops, I'm sorry. It said the barrel was full on May the 3rd, so it had 55 gallons. On May the 8th, which is 5 days later, it said she had 47 gallons of water. All right, so again, we can find our difference by finding that slope. So difference will equal 47 minus 55 over 5 minus 0. So negative 8 divided by 5, which is negative 1.6. All right, so the first 6 terms, we're starting out with 55. Then I'm going to subtract 1.6. Subtract 1.6. Whoops, that should be, I can't subtract 0.4. So then I get 51.8 minus 1.6 minus 1.6 minus 1.6. 1, 2, 3, 4, 5, 6. There's the first 6 terms of that sequence. Then it says write an explicit rule using both subscript notation and function notation. All right, so we know our A sub n equals our difference n plus A sub 0. Which means f of n is equal to the same thing. C says explain when the rain barrel will be empty, assuming there is no rain in the next 10-day period. Okay, so basically it should actually read, assuming there is no rain, period. Okay, so there's no rain at all while they're using the bucket to water from, the barrel to water from. So I want to know, when is this going to equal 0? Because that's when there's no water left into the bucket. Okay, so let's see, we get 55 equals, I'm adding the 1.6 in to both sides, divide by the 1.6, and we get n is 34.375, which means on day 35, the bucket will be empty. So we know then on day 35, the barrel will be empty. I keep saying the bucket, I'm sorry. The barrel will be empty. Now, if you wanted to, you could figure it out. So from May the 3rd to May 31, that's going to be 29 days because you have to include May the 3rd. Okay, so from 5/31 or 5/3 to 5/31 is 29 days. And then you got to add 6 more days to get to the 35. So it works out, it comes out that it's actually on June 7th. All right, in example 7. It says Alan is assigned a book to read for his biology class. Counting today, Monday, as the first day, he finds that he must read through page 385 by day 12 and through page 665 by day 20. All right, so what we know here then is from day 1 to day 12. So in the first 11 days, he needs to read 385. And then by the end of that, or by the 20th day, which would be A sub 19, he needs to read 665. Now this is letting today be day 0, okay? So counting today, Monday is the first day. This is our day 0, that's where we're starting. Okay, so that's why it's A11 and A sub 19 instead of A sub 12 and A sub 20. All right, so write a rule for the nth term of the arithmetic sequence. It represents the number of pages that he will read after n days, and it reminds us of the formula there. All right, so if I use the first one, A sub 11 is 385 as my A sub k in my k. So A sub n will equal A sub k, which is a 385, plus, but we don't know what the difference is. But again, we have some ordered pairs here, okay? So I'm going to come over here. And so D, which is, remember the slope, is going to be that 665 minus the 385 over 19 minus 11. And so we end up doing that. We find our slope is 35, which means he needs to read 35 pages per day. All right, so for plus the 35 times n minus, and that 385 was day 11. So we're going to put an 11 there, okay? Or it was A sub 11. B says, what is the common difference? What does this mean for his assignment? Well, we already found that. So our common difference was 35. And this means that Alan must read 35 pages per day in order to complete the assignment. All right, C says, based on your formula, how many pages does Alan need to read today on Monday, and explain how you know? Well, again, we said he has to read 35 pages a day, but if he needs 385 by day 11, so if we take that 385 and we divide it by the 11 days that he's going to have to read, that's still going to give us 35, okay? So, since he needs to read 385 pages on day 11, he should read 35 pages today. All right, using your function rule, how many pages will Alan have read by Friday's class? All right, so on Friday, that means he's read on Monday, Tuesday, Wednesday, Thursday, because we're going to assume he didn't read Friday before class, okay? So that's 4 days of reading. And that's at 35 pages per day. BPD, pages per day, okay? So this would give us 140 pages read by Friday.